Alright, welcome to the part 1 video of 1.3 quantities of atoms. In this slideshow, in this video, we'll be looking at the first science understanding part. The quantities of different substances can be conveniently compared with the mole unit. We'll spend a bit of time on what mole unit means. Alright, let's start. So, firstly, you might ask, what is a mole? What is mole unit? Alright, so it shows the quantities of different substances, and it is very conveniently can be described with mole unit. 1 mole is always 6.02 times by 10 to the power of 23. It shows how many particles are present if you had 1 mole. So think of like 1 dozen. When you think of 1 dozen, you think of 12. Hopefully you do. When you say 1 mole, I want you to think about 6.02 times by 10 to the power 23 particles present in the thing. Alright. So a mole unit can be used for number of atoms, compounds, and formula unit. So atoms, compound, unit. But they're all individual things. So atoms or compounds as a bit bigger particles, or a unit for ionic big structure. So if you look at 1 mole of, sorry, I shouldn't say 1 mole. For example, there are 6.02 times by 10 to the power of 23 particles, sorry, copper atoms present in 63.55 grams of copper piece. Or you could say there are 6.02 times by 10 to the power of 23 water molecules are present in 18.016 gram of water. So water is a molecule here, H2O is a molecule unit, and I was just counting how many molecules are there if I happen to have 18.016 gram of water. Hope you get that. Next slide. Okay, the pictures are there, but we'll start from the top here. So, unit for mole and symbol used is N. Sorry, the unit itself is MOL. The word version of it is MOLE, mole. But the mole, MOL is the symbol, unit, and the symbol used for number of molecules, number of mole is N. How big is the mole? We'll look at the video in class together. Hopefully we can have better understanding of what we are saying. Comparing dozen and mole, like what I was saying, for balls, okay, if you use the word dozen, you'd think of 12. But 12 items could be different from 1 dozen of baseballs to 1 dozen of tennis balls. Because the baseballs are a bit bigger compared to tennis balls, 1 dozen of baseballs would be 8 kilograms, and it's a lot heavier compared to 1 dozen of tennis balls, which is 3 grams. Try drawing that next to this diagram, which is a mole. And 1 mole equals to 6.02 times by 10 to the power of 23 atoms. If it was 1 mole of carbon, you'll be looking at 12.01 grams, whereas if you had 1 mole of lithium next to it, that would be 6.941 grams. So almost the half of carbon in terms of mass. Molar mass, well, something that I've been using in the last diagram as well was the mass number. That's what's written under each symbol on the periodic table, right? Like carbon, 12.01 is something that you've been using, hopefully. When it comes to molar mass, you could use that for element and also molecules. Mass number, that's what you can see on the periodic table, is what mass an element has per mole. And the unit used for it, for molar mass, is grams per mole. It's written as grams/mole or grams and dot means multiply. Mole with exclamation, not exclamation, superscript -1. That means mole is dividing gram, but grams per mole is how you read both of them. Mass number per molecule, molar mass is what it is. Symbol used is capital M. Now, because I want to differentiate that with lowercase m, which is for mass, I tend to use capital M, but double of them, double capital M, molar mass. That makes sense, doesn't it? Hopefully. So mm is a molar mass. Here's a question. What is the molar mass of chlorine gas? If chlorine gas molecule, which is Cl2. Now, chlorine gas has got 35.452 as a molar mass. Now, this mass is only for one atom. So you need to look at the formula for the molecule, which is Cl2. I might switch this back to this. So answer should be 35.452 grams per mole times by 2, because there are 2 atoms involved in one molecule. So you should get 70.904 grams per mole. Another question, what is the molar mass of water molecule? All right, then you need to look at the formula again. It's H2O. So there are 2 lots of 1.008 plus one atom of oxygen. So that would be 16.00. So you add them up. Make sure you can work with Bilmus. So 1.008 times by 2 plus 16.00. That should give you 18.016 grams per mole. And these are the questions that we'll do in class, question 12 to 15. So yeah, that's the end of this video.